pusstundu kaut ko pastāstīs par kaut ko. Paklausīsimies, ja meitenes? Mēs esam muldēji. Jā, pusstundu.
Hello everyone, I hope you can nicely hear me. Those who are having microphones on, it's nice if you can put you on a mute side. We are ready to go with our Timberdeck Academy 9th session. And just for your info, we do also the recording. The recording is on purpose that we can upload it and some of you can look that after or share it to your colleagues. But here we are. Welcome. And those who are here been before in October, you can react with Tammy that you have been in Academy before, and then we can recognize that we are not going to go so deeply in an introduction and discussion. Today's subject is strengthening a beam with full threaded screws, and we do some comparison with alternative solutions. So here we go. Overall, short intro. We try to fit in 30 minutes. Then we're going to have a case study. We have an external speaker, Eero Tukkanen from Taltech University. And then we do a little feedback and the intro on ending part with different subject. About ESSVE itself, shortly. We are leading here in the Nordic region, founded in 1970. Our offices are in 7 European countries here in North and East area, roughly 200 employees. We are also part of the Bergman and Perming group, and a good factor that we are selling roughly 5 million ESSVE screws in every day. And the positive thing is that we are in national-wide distribution, roughly 1,100 Nordic retailers altogether. So in hardware shops, we are recognized and with the green boxes and fasteners. Primary application area is foundation, building envelope, interior finishing, and outdoor carpenter. And if we look in more detail, then we are today and subject timber structure frame, glulam, and also in that foundation area is concrete. Who don't know, there is also QR code or website svood.essve.com. You're welcome to test it. It's a free internet-based software for fastener calculation in timber. Some words about myself. I'm in fastening business been more than 25 years. I'm a technical sales engineer in ESSVE, Nordic region and East. And you're welcome to ask my support. You find my contacts on the right-hand side. But today our lecture is a senior lecturer from University, Eero Tukkanen. The floor is soon yours. He's technically super good. He's a member also of Estonian Eurocode delegation. And if you don't find a question during the session, you are also welcome to send us in a chat field all the questions what you're gonna have. If you are not able to answer all them during this session, we will send you an email as a feedback. Thank you, and here today's subject. Eero, feel free to take the screen.
Good morning, everyone. Thank you, Anna. Can you confirm my shared screen?
Yes, I do see your shared screen.
Yeah, thank you. Anna already introduced me, and it's a pleasure to be here again. Before I start, I will inform you that these worked examples which we are doing during this sessions, these are not fully complete because the presentation mode, it's very hard to give further everything in very deep detail, and I think in the beginning of next year you can have these worked examples in more detailed way as a real worked examples, but today I try to just show the principles when we have to reinforce the timber beams, which is today's topic. Where we need the reinforcement, or where we have to strengthen the beams, here I have two situations. One is change of the use. So if you change the use of building, let's say you have a building in Old Town, you have under the roof empty room, and you want to make a living space there, or if you want to change the room in that way that more people can use that room, then you need to consider higher loads, and therefore you have to strengthen the beam. And the other situation can be that you have to consider some architectural considerations. Let's say you have a rafter, you have to keep the rafter outside very slender, and you have to strengthen that with additional beam. Then you have to connect them together to act as a one beam. And today we are trying to see the options to strengthen the timber beam. First slide, the effect of increasing the cross section. So this is very basic for everyday engineer, but just to keep in mind that if we have a cross section and we want to make it wider, so we add some additional parts to the cross section, this has a much lower effect than we increase the height of the beam, because section modulus and the moment of inertia, the height is here in square and here is exponential. So we can increase when we can increase the height of the cross section, then it has much more effect on the load bearing capacity and the stiffness. So we have to keep that in mind. But it's not always possible to increase the height because of the restriction of the floor height, let's say, and then we have to find another way. And today we are going through both options. Here are some options. It's additional side beams, so we can add some additional beams. It can be steel or it can be timber to increase the width of the cross section. And here we have to keep in mind that every beam has its own bending stiffness, and when we get the load on the beam, it will be shared according to this bending stiffness. So when we have a stiffer beam outside, let's say steel, then the steel beams take more load than the timber in the middle, and you have to check both against. You have to check both strength, steel strength, and also the timber strength. But here, it's also different options to add the side beams. Let's say we have a beam without any reinforcement, it's a timber beam alone. So the simplest way is to add additional side beams which are supported in the end. So it means that every beam can act as a separate beam, and it's easy to calculate this situation. But it's not always possible to add the side beam in the entire length. One reason is that we cannot maybe destroy the structure where the main beam is supported. We don't want to make additional hole for the additional beam, and in that case, we need to make this additional beam shorter, to add that in the middle part to increase the bending capacity and stiffness, or we can also add the side beams, timber beams on the both sides to increase the stiffness and the bending capacity. My own experience is that if you have the beam without reinforcement and you add some additional beams on the both sides, usually you can reach the load carrying capacity or ultimate limit state very easily, but it doesn't help too much against the deformation. It means that the serviceability limit state is not okay in that case, and then you have to go and add something more stiffer, let's say steel beams. If you calculate them, you can also see that the stresses are more, stress distribution is more equal when we add timber beams on both sides. But when we add steel beams, then the main load is taken by the steel part, and these steel parts are loaded much higher than the timber between them. In this situation, the most complicated part is how to connect the main beam with additional beams on both sides. In the last slide, I had some points you can see. These are connections between the main beam and additional beams, and how to find the load which is acting in this connection point. And here I can suggest two options. One is a graphical solution. It's very old paper from Brel. I found I can share that with you. If you write me an email, I can send it to you because it's not available online. I ordered that from a library. It's in German language, but as we know, every timber engineer can very well German. So you can use the graphical tables to find the forces in the connection when the additional beams are not supported. But maybe more modern way is to use finite element method. Finite element method, you can model the connection points, and you can play around to find the best position to lower the forces in the connection. So here are two examples which I made for this presentation. Here I have one example from, I think, 10 years ago, where is a strengthened timber beam, and it's the problem here was not the load carrying capacity, but the stiffness was a little bit low, so that serviceability limit state was not reached. And here we used to add the stiffness, we used additional timber planks from both sides, and as you can see, the length of the original beam is around 6 meters, but it's very hard to get the sawn timber longer than let's say 5.4 meters, and we used here shorter beams to add some stiffness. And here these side beams are installed that way that we leveled also the floor with the new side beams. So you can adjust the new floor level because the old beams can be very can be on very different levels. So just to get a nice floor after that. So the second option, and much better option to increase the stiffness and load carrying capacity, is to increase the cross-section height. And here are different options to add another piece of timber on top of the main beam. You can also add concrete on top of the beam or between the main beams. And here are some options to connect the additional beam to the main beam. Here is a connection with a bolt. Here is connection outside with plywood strips. Here is also option to connect that with this. Yeah, I can't remember this the name of the connection.
Cobble, probably
Yeah.
Cobble is that.
Yeah, thank you. And here are some options to use so-called bulldog tubules, which are also very good option. Additionally, to add this bulldog tubule to the bolt, because this connection gives bigger initial stiffness. So this connection can act immediately after loading, but bolt connection has some loose here in the connection first at the first place, and after increasing the load, the bolt will act as it should be. But all these options are quite complicated to do, because you have to drill the hole, you have to press the timber parts. Sorry, I lost the connection. Can you hear me?
Yes, now we can hear you again.
I don't know, I had some blackout in the screen.
Yeah.
So yeah, let's continue. I will. Just a second. I really don't know what happened.
You just took off the screen sharing. Probably have to share the screen again.
Yes, but I lost also the connection in the microphone.
But we hear you well, Eero, and you can continue now.
Yeah, but I try. Yeah, now it works. So sorry about that. But yeah, these options are complicated to make, because you have to drill the hole and make the proper press to get these timber parts together. And these are also not fireproof, because you have steel parts outside of the timber, and these are not looking good as well. And the better option, or more modern option, is to use full threaded screws to connect the additional beam. And here I have this worked example, which you can get in longer versions soon. But the principle here, how we calculate this strengthening of the beam. Let's say we have a timber with a cross section 180 times 220. We don't know, when we have old timber, we don't know exactly the strength class, and we have to assume that we have some permanent load on the floor, and let's call it new live load, which is 2 kilonewton per square meter. And as we see, when we calculate this, we have load carrying capacity lower than the bending moment in the beam, and the serviceability limit state is 160%, so it means 60% over. We can add additional beam or additional cross section on top of this main beam. It's selected 200 times 100 millimeter cross section, and it's calculated according to Annex B5, which is new Eurocode. In the new Eurocode, you have this annex for mechanically jointed members. It means that you have two members which are mechanically jointed, and this mechanical joint is this full threaded screw. And the idea is that you have to find effective bending stiffness, but for this effective bending stiffness, you have to calculate so-called gamma value. Gamma is considering the stiffness between these two members. And according to this calculation, you can calculate the force in this screw, in this full threaded screw in the connection. And the way you can find the force in the screw is that first you have to calculate this gamma value, and for the gamma value you have to give first the step for the screw. This calculation is iterative, so it means that you give some step for the screw, then you calculate it through, and you can then check is this force in the screw too high or too low? And according to that, you can recalculate this gamma value to increase the step or make it smaller to make more screws. So it's an iterative process. But the other thing here to calculate this gamma value is to find the stiffness of the screw. You have to know the stiffness. Some producers will give you in the ETA document the stiffness of the screw, but if you don't know the stiffness of the screw, you can find in the new Eurocode the stiffness calculation. You have this stiffness perpendicular to the grain, or when the connection is loaded perpendicular to the grain, and then you can calculate the stiffness in axial direction. So if you have the screw, you know the parameters of the screw, you can calculate the both values, and you have additional formula for the situation where the screw is placed under the angle of 45 degrees, let's say, here in this situation. And you can find this stiffness of the screw according to this long formula here. So, and so it is possible to find this gamma value and check whether the force in the screw is enough or not. In this worked example, you can get this full calculation row, how it's calculated, but the main thing is that first you have to say what is the step of the screw and what is the stiffness of the screw. Conclusion, if you strengthen the beam in that way and you calculate the stresses and forces in the screws, we can say that if you consider this cross-section as a full cross-section without mechanical connection, let's say it's glued here, then the screw, depending on the stiffness, has approximately 20 to 30% lower load-bearing capacity as the full cross-section. So you can check your calculations in that way. Is it comparable or not? So that's the kind of proof that that you have calculated that right. So yeah, but this really you really have to know the stiffness of the screw between two members. When you have very stiff connection, this percent is lower. When you have a very loose connection, then the percent is higher. So it's depending on that. So that's all from my side. Unfortunately, there was some blackout in the meanwhile, but I hope you did get everything I wanted to show.
Thank you, Eero. As we are a little bit time pressure, hopefully you recognized his contacts. If not, feel free to ask in the chat area. We probably coming with questions and answers as a feedback to you whenever you ask. But I'd like to also make a quick intro for another subject, what we wanted to pass it. And before we jumping in that, I raise you also one so-called poll. You will have just yes, you have heard or not, but the question is related to timber also once in a while used concrete software. And do you know anything about it from ESSVE side? And that is the question. Step forward to go here and give a quick answer for Eero's message that we're gonna work on one PDF document where is all the calculation models in it, and those will be presented in Winter Academy around February. So keep looking our info also there when we invite you for the next academies. But now we go forward with DR, and we have in East your technical support Radek, who is not with us today, but DR help to show a little bit and very quick ESSVE CS concrete software. And DR, if you're ready, then the floor is yours, and you can maybe give some words about it. We are having a time for you now. Are you with us?
I'm ready. Do you hear me?
Yeah, I heard you.
Yeah. Thank you, Eero, for the great presentation. As you say, we don't have any much time to present our program. CS is about concrete connection to the steel. I'm almost sure that you are familiar with a similar program. We have it. This program is very easy to add your addition profile and the load. Now I have already prepared some profile. You can come in here and you can change the language from Swedish to English. I will change it here. Here you can change the profile from, we say, one which type beam or column you need. I choose 120 by example. You have the plate dimension, and here you can put some loads. You see here, if you don't put any load, you cannot get any result. But if we put like 20 by example and click OK, so you see that you get the answers which screw. Here is chemical anchor we can use. Here you can use concrete. You see here that is saying that 7.5 millimeters concrete screw is not working. You have optimization by 200%. If I change and put like some, by example, put some moment too. If I put like example 5 moment, 5 Newton moment, you see here you get some red in the result. And if we choose M10 or M12, you get pass, and it's 60. It's about optimization about 92%. But if we look at the red one, but if you just keep your mouse on it, you will see the Y is not passing. It give you some very clear information about the why. If you want this answer, use the screw. You get the answer. Otherwise, you can choose the other screw. And what's the good with our program, that if you, by example, we change the distance. By example, we have here 150. If we choose like 200, by example, you will see it saying to you that M12, M24 is not working anymore, because of the age distance of the plate, which is very initial check for you if your plate is good enough or not. And at the same time, if we choose, we can have another option that you can come in here under calculation and do like PEM design calculation, and at that time the program give you some like choose alternative, which say that you can choose another type of plate, which is according to finite element calculation. After you did your calculation, you come in here. If we choose like 10 millimeter screw, you can just come in here to click to the report down, and you will see according to the report how the connection is checked and where is the weak part in the connection if you want extra check. This was very short and summary about our CS concrete connection. I don't know if you want to hear about more. We can have a longer presentation about CS, which we talk about not just the profile. We will talk about which type of connection you can choose and what's your base our ground material, and how you should thinking if you get something like red hair, how you can analyze and to avoid have this red solution, or you can choose otherwise of other type of screw. Yes, it was very short from my side. Thank you, Eero, for this time. If anybody have some question, please ask.
Thank you, dear. Super good. I would say that I see in the chat field that roughly 95% have given a yes to hear more about CS concrete software. We probably will pick that up on winter spring academy area, because so far the December and January, February planet. But here some product range. Why I show that product range here is in focus that we are having another option also for you.
If you go back, Eero.
Yeah.
No, sorry. This is like a summary of our concrete product, which is anchor screw, concrete screw, shimmy, and a special solution for the thin concrete, like prefab for the, or you have very thin concrete and you want you need like connected and you have very high load. This is in Swedish, but I see the possibility, you know, if we see this, we have very big interesting for this program that we can do like external webinar, extra webinar during this time before the New Year's, the New Year.
We will bring that as a subject in for extension for timber in the future. What I wanted to say in the meantime, when you test maybe the concrete calculation program, we also offer in Eastern Europe the pull-out test on site. Poland, Lithuania, Latvia, and Estonia are having the pull-out testers. In Estonia, we have additional also share test on construction site soon available. So feel free and contact us directly if you see that there is a renovation business or something ongoing. To end now is next academy we're gonna have 3rd December. Then we talk about lateral connection, little bit bring in also alternative, which is some metal brackets, but focus on screws. And to finalize the day, just we run over time, and as we run over time, it's good to ask your feedback. What is your reaction for the day's academy? Was it positive? Was it satisfying your need? How did you evaluate that? So happy to get your feedback. See you in 3rd of December. The answers, Eero nicely also answered in the chat field. And if somebody feel that they still wanted to ask something, you are welcome to add some more questions here, and we will come back to you with the emails. Thank you very much. Wish you all best. See ya.
Thank you. Bye.